It's time for the lecture on conditionals, which is usually something that trips a lot of people up. So conditionals are of the form P arrow Q. And there's three other terms we can use when talking about conditionals. One is the converse. So the converse of the conditional, if the conditional is P arrow Q, then the converse is flipping the order. So the converse is Q arrow P. So that's flipping the order. The inverse is taking the conditional and just adding negations in front of each formula. So P arrow Q, the inverse of P arrow Q is not P arrow not Q. Finally, the contrapositive is doing the converse and the inverse. So the contrapositive is flipping the order and putting a negation before each proposition. So P arrow Q, the contrapositive is not Q arrow not P. So which of these are logically equivalent? Well, the conditional is logically equivalent to the contrapositive, and the converse is logically equivalent to the inverse. So that might seem a little bit counterintuitive, but using the conditional law, we can see this is true. So using the conditional law, P arrow Q is logically equivalent to not P or Q. The contrapositive, not Q arrow not P, is logically equivalent to not Q or not P, but using double negation, we can get rid of the two negatives, and we're left with Q or not P. And these are logically equivalent. Similarly with the converse and the inverse, the converse, Q arrow P, is the same thing as not Q or P, and the inverse would be not P or not Q, and of course the double negation just removes them, and we can see once again these are also equivalent. So keep in mind, this is really the most important thing in this whole video. The conditional is logically equivalent to the contrapositive and nothing else as far as converses and inverses go. So, we talked about the conditional, we introduced the biconditional in a truth table. Let's formally define the biconditional. The biconditional is not a standard operator. It is usually defined in terms of the conditional and the conjunction operator. So P, if and only if Q, is the same thing as P arrow Q and Q arrow P. In fact, we can see this in a truth table. So P, if and only if Q, was 1, 0, 0, 1. So it's true if the values are the same. Now P arrow Q was going to be false when P is true and Q is false. So P arrow Q would be 1, 0, 1, 1. Q arrow P would be 1, 1, 0, 1. Of course, I really should do the P and Q values here too, so you can see exactly what the P and Q values are. Now, what is P arrow Q and Q arrow P? Well, it's true when both of its conjuncts are true. So it's going to be true in the first row, true in the last row, and in the second and third rows, they're both not true, therefore they're false. Therefore, this P if and only if Q is the same thing as P arrow Q and Q arrow P. So the biconditional is actually a conjunction of two conditionals, which makes sense because the biconditional is if and only if P arrow Q is the same thing as P only if Q, and Q arrow P is the same thing as P if Q. So the biconditional is P only if Q and P if Q, which would be P if and only if Q. Now let's do some practice translating these. So here I have I will pass if I get a good exam mark. So I will pass, let's call this P, and I get a good exam mark, let's call this G. So I will pass if I get a good exam mark. So this says G arrow P. So if I get a good exam mark, then I will pass. This means that if you get a good exam mark and you don't pass, then it's false because that's a lie. Let's compare this with I will pass only if I get a good exam mark. So this is actually the opposite. So this is P, then G. I will pass only if I get a good exam mark. So what this says is if I pass the course, if this is a 1, if I do pass, then I better be getting a good exam mark. So I will pass only if I get a good exam mark. This says if I pass, then I better have gotten a good exam mark. So if I pass, but I don't get a good exam mark, then this is going to be false. I will pass only if I get a good exam mark. This says that I passed even though I didn't get a good exam mark, which is a lie. So that is the difference between if and only if. So just keep that in mind. The thing after if, so I will pass if I get a good exam mark would be G arrow P. So if I get a good exam mark, then I will pass. I will pass only if I get a good exam mark is like saying if I pass, then I will get a good exam mark. And think of it in terms of lying or not. So I will pass only if I get a good exam mark should mean that if I passed, then I did get a good exam mark. Now, of course, I will pass if and only if I get a good exam score. This would just be P biconditional G. And this makes more sense usually in terms of English at a university, for instance. So if you get a bad exam score, then normally you don't pass, and if you get a good exam score, then you do pass. So these two are very closely related in terms of the biconditional. In fact, I would say that this is usually what we mean in English when we say things like this. Oh yeah, if I don't do good on the exam, I won't pass. But if I do good on the exam, then I will pass. And that's an if and only if statement. So, in order to wrap up this video on conditionals, I have a story here. And this is a real story with changed names. And I love this for logic. I love this for conditionals. So I'll read this out to you. So Mark is writing an exam on propositional logic. During the exam, his professor, Dr. Cheatenheimer, notices that Mark is acting rather suspicious. Suspecting Mark of cheating, Dr. Cheatenheimer walks up behind Mark and notices a cheat sheet. Dr. Cheatenheimer says, "If you don't give me your cheat sheet, then you will fail the course." Now, Mark isn't a very good student, that's why he has the cheat sheet. And he doesn't want to fail, so he gives Dr. Cheatenheimer his cheat sheet. And of course, after reviewing the cheat sheet, Dr. Cheatenheimer fails Mark, so he doesn't pass the course. Now, the question is, did Dr. Cheatenheimer lie to Mark? So, he said if you don't give me your cheat sheet, then you will fail the course. But he did give him his cheat sheet, so should he have been allowed to fail Mark while still telling the truth? And the question, did Dr. Cheatenheimer lie to Mark? The answer to this is no, he did not cheat. So let's formulate this. If you don't give me your cheat sheet, so not C, then F. So let me actually put this down here. Not C, then F. But Mark gave Dr. Cheatenheimer's cheat sheet, so he gave him his cheat sheet. Now, what does that imply? Well, what's not C arrow F equivalent to? It's contrapositive, right? So not C arrow F is equivalent to not F arrow not C. Or in other words, not F arrow C. Now, this doesn't tell us anything about C. In fact, the inverse would state not C, arrow not F, which would become C arrow F. So the inverse states that, well, if I gave him his cheat sheet, then I wouldn't fail. But the inverse is not logically equivalent to the conditional. So in fact, it doesn't matter whether he gave him the cheat sheet or not, he was probably still going to fail. So, of course, Mark isn't a very good logic student, so he didn't think of that at the time. But this kind of brings up an important discussion question, right? So, if we were to say something like, if you don't do the dishes, then you won't get paid. But if you do the dishes, that doesn't mean you're going to get paid. It just means if you don't do the dishes, then you're absolutely not going to get paid. It doesn't say that if you do the dishes, then you will get paid. So this is one of those things with conditionals that is kind of tricky to keep in mind. You're not being a smartass by saying, well, I never said if you did do the dishes, then you would get paid, because it's actually logically true that that's not required. So you're not being a smartass, you're just being logically sound. So that's it for conditionals. If you have any questions, of course, feel free to ask, and I will do my best to respond to them.